Hello, PreCalc. We're looking at logarithmic functions today. I wrote it twice, so I was testing the color of the chalk, so you're not seeing double. Let's look at the logarithmic function, and you haven't had logarithms yet, but it boils down to this fact. If you would write it, please. Switch to yellow. Try orange. A logarithm, and from here on in I won't call it a logarithm. I'll call it a log. So a logarithm, that's the last time I'll probably say it that way. A log is an exponent. We've been studying exponents and exponential equations, so a log is an exponent, and that is all it is. So we could say it another way. An exponent is a log. So a logarithm is simply an exponent. So if you understand this statement, 10 squared equals 100, you have a base number. Remember, we call this the base number. Raised to an exponent equals another number. That is the same information as it is in this statement. Log to the base 10 of 100 equals 2. So that is saying the exact same thing as this. There's no more secret information than this in this statement. So the base number is written in a smaller script to the lower right of the word log, so it's a subscript. Log, and it's read log base 10 of 100 is 2. So this is saying what exponent? Remember, a log is an exponent. So when I see the word log, I'll say to myself, what exponent? What exponent do I give this number 10 to get this number 100? That's all a logarithm is. So what exponent do I give 10 to get 100? And the answer is 2. Do you see these have the same information? We call this exponential form. We call this logarithmic form. Call it log form. So I'll give you a couple, and I'll ask you to go from one form to the other so you get used to it. Let's say I say log to the base 4 of 64 equals 3. Obviously this is in log form, the word log appears, so I want you to write it in this form, exponential form, without the word log. So we search for the base number, which is always the little one. We raise it to the exponent, which is the logarithm, and we get the number. So 4 raised to the 3 is 64. It's the same information on both sides. All right, let's try one more of those. Let's say I start with 5 raised to the 3 equals 125. So I'm in exponential form. So I want to write that in log form. It starts with the word log. What's the base? What's the smaller number to the lower right? The base is this number, which I taught you when we were studying exponents. So this is log to the base 5 of this number is this number. So you can see the exponent is the logarithm. Alright, so log to the base 5 of 125 means 5 raised to the 3 equals 125. So part of your assignment tomorrow, we were going from log to exponent form and exponential form back to logarithmic form, like those two examples are. Alright, let's get even more basic than that. It's talking about logarithms in general, and actually how to calculate a logarithm. So what if I said to you, I already gave you this one, log to the base 10 of 100 is 2. So this is saying what exponent do I give 10 to get 100? And that exponent is 2. What if I do this one? Actually, if you would write down all of these examples and put in the answers, I'll come back and tell you what the answers are, and you can see how well you did. Oops. All right, let me see where that is. Go ahead and work on those. Alrighty, I'm going to move it slightly that way and do another list. Alright. Write all of these down and fill in what the logarithms are from what you've learned so far. You may pause it, so I'm going to go ahead and write the answers in with minimal explanation on this side, and I will explain this side. So pause and finish that work. Log the base 10 of 1,000, what exponent do I give 10 to get 1,000? What exponent here do I give 2 to get 4? What exponent do I give 4 to get 16? What exponent do I give 2 to get 32? What exponent do I give 4 to get 4? So I'm expecting success on this side. This side, I'm also expecting success, but you'll have to think a little harder. So what exponent do I give 6 to get 1? Oh, algebra students. Anything raised to the 0 is 1, so the answer is 0. What exponent do I give 4 to get 2? And we talked about those kind of exponents, and you remember that the way we get from 4 to 2 is take the square root of 4, and that exponent is 1/2. We also talked about negative exponents. Did you pull one out of your hat on this one? What exponent do I give 2 to get 1 over 64? Well, I think in my head, what exponent do I give 2 to get 64? With 2 times 2 times 2 times 2 times 2, 6 times. 2 to the 6 is 64, but we want the fraction 1/64. So we're going to use a negative exponent. So I'm going to give 2 the exponent of negative 6. And we had covered those recently. Is not 2 raised to the negative 6 1/64? And this one, what exponent do I give 10? So here's my thoughts. What exponent do I give 10 to get 1/3? Alright, this one is, I wanted to show you how to do one on your calculator that doesn't come out evenly. So to do that, you're going to find the word LOG on your calculator, and the calculator knows that LOG is base 10. So you can't use the LOG button except base 10 problems. It comes up so often that we call it the common log, and we just write it LOG. So everyone knows that LOG is base 10. So I'm going to write LOG, and then I'm going to give it the logarithm, the answer 1/3. LOG of 1/3, and it will give me the exponent. When I did that, I got negative 0.4771213. So let's check that. Let's see if we raise 10 to the negative 0.4771213. Do you get 1/3? Something very close to 1/3. All right, so check that one. And the last one, what exponent do I give 10 to get negative 2? What exponent do I give 10 to get negative 2? So it turns out that there is no exponent that you can give 10 that will ever create a negative number. So this one is a no-go. All right, I'm going to shut down this portion and then pick it up with some graphing.